second law of motion can be applied to the motion of my car when the sum of forces, acceleration, and mass are all taken into account. Let us first examine the forces acting on a car at rest. Here is a free body diagram depicting the normal force and force of weight acting upon my car. My car weighs 15,000 newtons, and the normal force of the earth pushing up on my car is 15,000 newtons. Newton's second law of motion says that the sum of forces acting on an object will equal the object's mass times its acceleration. This problem represents the sum of forces present when my car is at rest. 15,000 newtons is converted to 1,529.57 kilograms, and the acceleration is 0 meters per second squared. One would multiply these values to figure out that the sum of forces within the system is 0 newtons. Newton's second law can tell us a few things about this particular set of forces. For one, the sum of forces acting on my car in this example is 0 newtons. Second of all, there is no acceleration present. Because there is no net force acting on the system as a whole, implying that there are no net forces in the x and y direction, one can conclude that the car is at rest. What would the sum of forces look like on my car if I traveled at a constant velocity? This free body diagram depicts all of the forces in the system. In applying Newton's second law to my car at a constant velocity, acceleration still equals 0 meters per second squared. This results in the sum of forces in the system equating to 0 newtons. The sum of forces in the system, both in the x and y directions and as a whole, is 0 newtons. The car is traveling at a constant velocity and therefore does not accelerate. In this instance, my car is in motion at a constant rate. What would be the sum of forces on my car if I were to accelerate? My car, with an increasing velocity going in the positive direction, has an acceleration greater than 0. In turn, this makes the sum of forces acting on my car increase. This equation represents the application of Newton's second law of motion with a constant mass, which is my car in this case. The sum of forces and the acceleration have a positive correlation mathematically. Basically, if you're working with an object, which by definition has mass, and there is a changing velocity, the sum of forces within the system will not be 0. There will be a net force. In conclusion, the sum of forces equals mass times acceleration. This is Newton's second law of motion. We also learned that the sum of forces, or net force, on an object at rest is 0 newtons. The sum of forces, or net force, on an object with a constant velocity is 0 newtons. The sum of forces, or net force, on an object with a changing velocity is not 0 newtons. A net force results from a change in velocity or acceleration on an object with mass.